Okay, again, so this next video is kind of a brief follow-up to the one that we posted on Canvas already by way of introduction. Hopefully you had a chance to take a look at that. That's the video where we defined what a vector field is and examples of how to construct them, right? It's going to be a field of vectors. And what I wanted to do in this particular video and the next one after this is highlight two specific or special cases of vector fields that we're going to encounter often, if anything, in chapter 15. But a lot of you that indicated that you're studying physics and engineering, you'll see these quite often as well. In fact, a lot of the terminology, I might as well mention this now, that we use in Calculus 3 is kind of borrowed from physics and engineering, okay? In particular, the study of electromagnetic fields and this kind of stuff, okay? All right, so the first special case, gang. Okay, let R equal xy. That'd be like a position vector, okay? This is a special kind of a vector field, gang, and these are referred to as radial fields. Note in this case right here, we can write like this if you like. Okay, they're called radial fields, and here's why. When you graph these, gang, what you're going to find is that the arrows are either pointing away from the origin or they're pointing towards the origin, okay? And notice down here that if you, this is right here, that's the magnitude of the vector r itself, right? Right, that's the magnitude of your vector r. And so as an example of what that might look like, so we'll take one that's kind of easy, right? Okay, and we'll just plot a few of them. All right, now, like we said, in the previous video, you saw how to construct a vector field by hand. I'll just choose a couple of convenient points, gang, so we can kind of fit it on the whiteboard right here. Let's choose, for example, 1, 1. Okay, so f of 1, 1 is 1, 1. All right, so from that dot, count 1 unit to the right and then 1 unit up. Okay, notice that the vector points away from the origin. If maybe I choose a point down here. Okay, so at that point, the vector is going to be also 2, -3. So using that point 2, -3, from that dot, I'm going to count 2 to the right and then 3 units down. Okay, and on we go. You fill the whole thing up with vectors, okay? Let me just mention this to you as well, gang. In pencasts and any presentations that follow, wherever we can, I'm going to use the Desmos program to generate our vector fields, because typically doing these by hand, I mean, you can do it. It can be tedious, especially if the components of the vector field are kind of involved with square roots or whatever, okay? But Desmos is pretty good at those kinds of things. So we'll appeal to that whenever we like. All right, so this special case of a vector field, these are called radial fields. Okay, radial fields. Again, these are going to figure prominently in things like gravitational fields and electric fields and other things as well. Okay, so maybe this represents the velocity of a fluid, right? At any point within that fluid, it can be that as well. Sometimes we refer to those as velocity fields. Okay, in this case, everything would be moving away from the origin. We'll see many different examples. Okay, in the next video, I'm going to show you the second specific or special case of the vector field, and those are called gradient fields. Okay.